Appreciate it very much. And I wish I could shut off my announcements here. Let me just do that real quick. If I can do not disturb for an hour, that would be great. All right. Well, good evening, everyone. My name is John Meter. I am the director of Northern Stars Planetarium, and I am the vice president of a nonprofit called Dark Sky Maine, which is encouraging towns and organizations like Rangeley Lakes Heritage Trust to work towards preserving their night sky. And so my aspect comes from an education. So I would like to help you by taking a look at the sky you would see if you went outside tonight. So I'm going to get rid of my picture here, and so we get better bandwidth. Hopefully you can still hear me. I'm going to share my screen, and we're going to dive into the sky you would see outside tonight. So let's see if we can do this. We're going to go right to Stellarium. And one moment. So hopefully now you are looking at the western night sky. And this is actually the sky you would see tomorrow night. Since we're all sitting, I had it all set up for tonight, but I realized that we're all sitting inside looking at our computer screens right now. And the sky pretty much is going to be the same tonight as tomorrow night. The only difference is the moon. The moon's a little bit lower tonight, and it's a little bit higher tomorrow night. We can see it a little bit better. And I want to start off talking about the moon. This is at 8:15 tomorrow night, which is very close to what it'd be tonight, except the moon's in a slightly different spot. If we were out tonight, if we walked outside right now, the moon would be right about here. So it's going to move to the east just a little bit. So the first thing you're going to see after the sun goes down, look in the westerly sky, and you're going to see a beautiful little crescent moon if you get outside right now or tomorrow night around 8:15, as you can see right here. And at this point, you can see a lot of stars here. If you're outdoors at 8:15, you're probably not going to see quite this many stars. Computer programs aren't exactly perfect the way the sky will respond outdoors, but everything that's here is accurate. So since the moon is going to be the brightest thing in the early evening sky, I thought we'd start with the moon, and then we'll let it get a little bit later and get the moon down a little bit lower, and we'll take a look at the stars. So let's start off by zooming in on the moon like you had a pair of binoculars. I'm not going to worry about whether you have a telescope for this, because the moon is a wonderful thing to look at with binoculars. In the telescopes not only make things bigger, but they make things much brighter. And very often the moon is so bright, it almost hurts your eyes. You won't damage your eyes, but it doesn't help you dark adaptation by looking at the moon. But when there's a crescent moon and it's low in the sky, you want to catch it early because it's going to set probably within 15 to 20 minutes after the sun sets. So this is the moon you see tomorrow night at 8:15 in the evening. So the crescent moon, this is called a waxing crescent moon. That means it's getting a little bit bigger from night to night to night to night. We had a new moon last Saturday, and then Sunday night we had a little thin crescent. Tomorrow night it's going to look like this. The next night it'll be lit a little bit more, and it's slowly working towards a full moon. If you do have binoculars and you zoom in on the moon like we've done here, the place you really want to explore is this line between daytime and nighttime on the moon. You know, the dark side here it's dark because it's nighttime. The sun's not shining on it. The sun is shining on this side. That's why it's all lit up. When you look along that line, that's called the terminator line, the line between day and night, shadows are long at sunset. You go out some night and look at the sunset, turn around, look back at your shadow, and you see you have a big, long shadow. Shadows give us contrast. It makes the craters pop out. You see these 3 craters here in a row and lots of craters down through here. You look over on the edge over here, you don't see many craters. They're there, but the sun's shining right straight into them, and there's no shadows to give us that contrast. So you can see some of them, but they'll show up a lot better when you have shadows. So this is the place to always look. Wherever that line is on the moon, that's where you really want to do the exploring. Now, if you don't have binoculars, you aren't going to see an awful lot of craters. You'll see these big dark spots, and you've probably all seen those before, like this one right here, these areas through here. And if you look, you can just barely make out some of them in the dark side here. A lot of people think those are craters, but they're actually not. They're what we call the maria. Each one is known as a mare. That's an old word which means ocean or sea. Some people suggest that a long time ago, people thought they were oceans and seas of water on the moon. Actually, if you really read your history, back in ancient times, the moon was considered to be a perfect sphere. and there were no imperfections on it. And those dark spots were believed to be the reflection of the Earth's ocean on the moon. Well, we now know that no matter how you look at it, there's never been any water in these oceans. And the moon is not a perfect sphere. There are craters all over it, craters like these little circles here. Those are made when rocks from space collide with the moon, making big holes. The Maria are hardened lava flows. Millions of years ago, the volcanoes erupted. A few craters were deep enough that magma from deep inside the moon oozed up through the bottom and filled the crater with lava. And lava hardens as a very dark colored rock. So these dark areas here are all hardened lava flows on the moon. Now, volcanoes don't erupt on the moon anymore. There's not enough heat left inside to make volcanism happen. So we're never going to see a volcano erupt on the moon, but we can see the hardened lava flows right here. Now, if you look very carefully with the binoculars right into the dark part of the moon, you just barely make out a very significant crater right down here. In a couple of days, they'll be lit up so you can see it really well. That's a crater named Tycho. And what I want you to look at, if you look at Tycho in 2 or 3 days when the sun is just hitting it, you'll notice there's a peak, a mountain peak right in the middle, similar to this crater has that little dot in the middle. That's a mountain. When the rock hits, it compresses the moon, makes a big hole, but it pushes the bottom way down. And then after the pressure is done, it bounces back up. And then the rocks fall right back in the middle, making a mountain. What's cool about the mountain in the middle of Tycho, this is a crater that's about 60 miles in diameter. And that's a pretty big hole. The mountain in the middle is about 1 mile high. That means it's about the same height as Mount Katahdin, Maine's biggest mountain. So if you look up at Tycho in a couple days, when this terminator line gets over near Tycho, with your binoculars, you'll see that little dot and realize that's what Mount Katahdin will look like from the moon looking at the Earth. It's the same size. That's just kind of a neat little thing. Well, let's back off and let's leave the moon behind. And we're going to go ahead in time just a little bit and let the moon drop down towards the horizon, get rid of the glare of that moon. We'll speed up time. Can't really do that outdoors, but we can do that here in our program. We're going to back off just a little bit more. And let's speed it up just a little bit more. Like, oh, that's probably pretty good right there. So now we've moved to just about 9 o'clock at night. The moon's getting lower. It's still shining, but it's lower in the sky, so it's not nearly so bright. We're going to look up high in the northwest, way over here. So to the right, if you're staring at the moon, look off to the right. I always think it's best to start with something that people are familiar with. And the one group of stars that almost everyone knows, if you don't know any others, is the Big Dipper. And the Big Dipper is semi-low, about 1/3 the way up in the northwestern sky. We have 3 stars for a curved handle. Follow my pointer. And then 4 stars for the pot or the bowl right there. Those 4 is the pot, and here's the handle. To me, it looks like a pot you'd cook with on the stove. This handle you grab and you put your mac and cheese in there and you got lunch going for the kids. Now, technically, the Big Dipper is just part of a much larger constellation called Ursa Major, which means the Great Bear. And to see Ursa Major, we can do a dot-to-dot bear. Now, you might say that doesn't really look much like a bear, but the way you imagine it is the handle is the bear's long tail. And I know bears don't have long tails, but in the sky, he does. And then the Dipper, plus you come way out to here, and this is the bear's body with the nose in front, and the front legs coming down here and back legs coming down there. Takes a little imagination, but we deal with what's there. Now, if you find a book, you might see a nice, beautiful picture of a bear, something like this. I always like pictures like that. The only problem is when you go out, if that's the only thing you have to identify the bear, and you look at that in a book or on an app on your phone, and then you walk outdoors and you look up, it's really hard to imagine that. Whereas it's much easier to imagine a dot-to-dot thing, even if it's a little weird looking like this. But if you can't see the bear, just settle for the Big Dipper, which you can see drawn right in here, the pot and the handle. Now, there are a couple of interesting things here I'd like to share with you. And by the way, I saw someone come in with a comment here a minute ago. Do write comments in the chat, and we will get to all your questions at the end. And if it's really important, I'll have Sarah interrupt me, but we'll try to answer all your questions at the end and come back to things. What I'd like to point out now is the middle star in the handle of the Big Dipper. There are 3 stars there. Look at the middle one, and if you look very carefully, you might notice that actually two stars there. If you can't see it with your eyes, in ancient times, that was a test of the acuity of your sight, if you could see those two stars. Take out some binoculars and it'll show up much easier. Let's zoom in on it a little bit. I'll center it here. And you can see it's quickly turns into two. The fainter top one is called Alcor, and the brighter one underneath it is Mizar. So it's Alcor and Mizar. Is often referred to as the horse and rider, Mizar being the horse and Alcor being the rider. Now take your binoculars, and if you really have a little bit more power to the binoculars, you'll see there's really three stars there, Alcor, Mizar, and this fainter one that makes a little triangle from the three. That's called Ludwig star. Ludwig star was discovered in 1722, and it was named after a German prince, Prince Ludwig. And initially, they thought it might be a planet to one of the other stars because they had just kind of were in this planet mode where they were hunting for more planets. We know it's not, it's a star. So what started off at a glance looking at like one star has quickly turned into two and then three. But now you put the binoculars away and you take your telescope and you point it at Mizar. And when you magnify Mizar with a telescope, look what it does. It turns into two stars, Mizar A, the bright one, and Mizar B, the faint one. So we have 1, 2, 3, 4. And astronomers will tell you they look at the spectrum of the star. That's where you put the light of the star through a rainbow, through a prism to get a rainbow. And when they do that with Mizar A turns out to be two stars itself, and Mizar B also turns out to be two stars. So Mizar is not one star or two stars, it's four stars. The spectrum of Alcor suggests it's two stars, and this one turns out to be a single star. So when you look at the Big Dipper and you see that middle star in the handle, if all you can see is one star, you should know in your brain it's actually 7 stars. Isn't that cool? So that's the middle star, something you can explore with binoculars and even better with the telescope. And then, with a book, you can learn even more. Now, right above them is something interesting. See it up here. You see that fuzzy little spot? Looks like a fuzzy star right there. It doesn't help when I put that on top of it, does it? Let's zoom in and see what that is. Oh my goodness, look at that. This is called the Pinwheel Galaxy. Now, we live in a galaxy called the Milky Way galaxy. This one's called the Pinwheel, which is a kind of descriptive name. Our galaxy is a spiral galaxy like this, and the only difference is this one's twice as big as ours. Our galaxy has 200 to 400 billion stars. This galaxy has 1 trillion stars in it, so it's much, much larger than the Milky Way. It's about 170,000 light years away. Now, if you look at this, and you will need a telescope if you want to see this, you should realize that if it's 170,000 light years away, it's 170,000 light years in diameter. It's 21 million light years away. I'm sorry, I had my numbers mixed up here. 21 million light years away. So that means the light that's coming through your telescope and entering your eyes, that very photon of light that hits your eyeball when you look at this, left the galaxy 21 million years ago. So you're not seeing it the way it actually looks today. You're seeing it the way it looked 21 million years ago. So when we look at distant objects like galaxies, we really are looking back in time. And if someone's on a planet going around a star in this galaxy, and they have a telescope and they look at the Milky Way, they're going to see something that looks very much like this. Now, one more thing I want you to notice in this galaxy. We got the spiral arms, which are primarily made of stars, but you have these pink patches. See the little pink patches here and there scattered around it one way out here? Those are giant clouds of hydrogen gas, which are condensing through gravity, pulling it together, making it clump, and slowly each of those pink patches will turn into hundreds of stars. These pink spots are called nebulas, what scientists call hydrogen-2 gas clouds. And they are the birthplaces of stars. We see them in this galaxy, but we're going to see them in a few minutes in our own Milky Way. So let's zoom back. That's right here by the Big Dipper. Now, look at the handle of the Big Dipper. You see how it arcs or curves? If you follow the arc of the handle, it points you to a very bright star, which is conveniently named Arcturus. So you follow the arc to Arcturus. And Arcturus is in the constellation of Boötes, constellation most people never heard of. Everyone's heard of the Big Dipper. Maybe you've heard of the Big Bear, but Boötes, well, Boötes is the herdsman, and he's chasing the bear across the sky to keep them away from his herd. The only problem is, if you thought the bear didn't look like a bear, well, Boötes doesn't look much like a man either. This is Boötes. Looks more like a kite, perhaps, or as my kids always said, it looks like an ice cream cone. If you draw a line between those two stars, get my little thing off here, imagine a line here. I can't do that in this program. I wish I could. This triangle becomes the cone, and this circle above becomes a big scoop of ice cream. Now, you might say, yeah, it kind of looks like an ice cream cone or like a kite with the tails coming down here. But isn't it supposed to be a man? Well, you could say, isn't the Big Dipper supposed to be a bear? The main thing is astronomers don't really care what you see, because when they label constellations, they just put a boundary around it, like these polygons. Everything inside this polygon is part of Boötes. Everything inside this one is part of Ursa Major, the Great Bear. Astronomers don't care how you connect the dots. It's a way of mapping the sky. So if you have an app on your phone or on your iPad or your laptop or something, if you have two or three, you'll notice they might draw the pictures a little differently from each other, though they use the same basic stars. They'll always be within these polygons. So I think the polygons are a pretty boring way to look at constellations. So I tend to like the dot to dot, but you can put, fancy drawings on there. But when I look at that dot to dot and try to turn that into that man, that presses my ability for my imagination a little bit. So I just turned it into Boötes, the ice cream cone, because I lean away. My kids want to see it. So now once you find the ice cream cone, right beside it, you're going to notice a nice little half circle right here. Let's zoom in so you can see it a little bit better. And this little half circle is called Corona Borealis, which means the northern crown. And so think of it like a tiara, like a princess might wear. The brightest star in the northern crown is this one right here. Its name is Gemma. Crowns are often covered with gems, so the brightest one is the brightest gem, so it's named Gemma. Now, what I want you to do is to imagine a line from Arcturus shooting up through the crown, keep going, and you come to a keystone shape right here. This is actually the body of Hercules. Hercules doesn't look much like a man either. I usually imagine this star up here is his head, and he's got an arm here and an arm there and a couple legs coming down. Sometimes they draw him the other way around. Again, draw it the way you want. What I want you to find is that keystone, because halfway down this side of the keystone, right about in here, is something you're going to want to look at with a telescope. You can even see it with binoculars. So let's zoom in and see if we can see something that doesn't look star-like. I can see it, but I know what I'm looking for. So you might start to see it. Let's get the lines out of the way. It's very beautiful. It's got the romantic name of M13. M stands for Messier, and Charles Messier was an astronomer in the 18th century, and he was hunting for comets. And so he found all these fuzzy spots in the sky, and he wanted to label them so he wouldn't confuse them with comets. He didn't get a view as nice as the one you're looking at right now. To him, it just looked like a very fuzzy star, like a star that someone tried to erase with a bad eraser. With today's telescopes, we see it's actually a huge group of stars, a cluster called a globular cluster of stars. There are two types of clusters. We'll see the other type in a few minutes. The other type is called an open cluster, and open clusters are young stars that form from those pink nebulas we talked about. And there might only be 300 or 400 stars in an open cluster. This is called a globular cluster, and these are very old stars, and globular clusters are found around the edges of galaxies, not deep inside them, but around the edges. And they have many, many stars. M13 has 500,000 stars in it. And our galaxy has about 140 of these globular clusters haloing the whole galaxy that we know of. So this is the best looking one you can see from the Northern Hemisphere. If you go take a trip to Australia or South America or South Africa, There's a couple that are even bigger and brighter than this that they can see from the southern hemisphere. So this is a beautiful globular cluster, and you can see lots and lots of stars. In binoculars, it'll look like that fuzzy star, kind of like what Charles Messier saw in the 18th century, in the 1700s. But with the telescope, you can discern them as individual stars. It'll kind of look like a little pile of diamonds, or as someone said to me, a kid said to me one time, I think it looks like a pile of sugar. This little boy said, I think I want to lick it. I'm like, no, don't go licking my telescope. Kids, as Art Linklater you say the darndest things, I guess, huh? Well, remember I said that globular clusters like that are, there's one right in Hercules right there, but I said globular clusters halo the galaxy. Well, we live in a galaxy called the Milky Way. And if you look further to the east, you can see the Milky Way arching across the sky here. So this is our galaxy. Now, kids often ask me, how far away is the Milky Way? It looks huge, but it looks far away, doesn't it? Well, it's not, because we are inside the Milky Way. These stars over here towards the Dipper where we just were, they're in the Milky Way too. And so are these stars over here on the side. They're part of the Milky Way. So you might wonder, well, if everything up there is part of the Milky Way that we can see, except for other galaxies that we need telescopes to see, like the Pinwheel galaxy we saw a few minutes ago, that's not in the Milky Way. But everything pretty much you can see with your eyes, except for one spot, which I'll show you in a few minutes. Everything you can see without a telescope is in the Milky Way. So people wonder, well, why do we have this band through the middle? Well, remember that Pinwheel galaxy looked round? If you could fly around to the edge, you look flat like a Frisbee if you hold up to the edge. And so they're round like a disc, like a plate or a Frisbee. But we're inside the Frisbee. We look towards the Dippers, where it's like looking out the top. There's a few stars above us. Look the other way towards the east, you're looking towards the bottom. There's a few stars underneath us too. But if you look edge on into the thickness of our Frisbee-shaped galaxy, you'd see a lot more stars, wouldn't you? That's what we're looking at when we look right through here. Now, we can't see the whole Milky Way because you see the ground gets in the way. It goes down below the ground. You know, it's not below the ground, but on part of the Earth we can't see. The nice thing about using these planetariums on your laptop is you can make the ground disappear. It's like you're floating in space. And now we can kind of see the whole Milky Way. This is the very center, and scientists believe there's a giant black hole. They took a picture of it back in April. You may have seen that, called Sagittarius A, which is right in the center here. A black hole equal to 2 million suns. Don't go there, bad spot to go. But you can see it stretches out in one direction and it stretches down in the other direction. It is a very huge object, and we are part of it, and we are inside of it. Well, let's put the Earth back, because I like being on the Earth. And we can see right to the core, and then the other part disappears below the horizon at this time of the year. Well, right down at the bottom of the Milky Way, near the horizon, we have two really wonderful constellations. And I'm going to zoom in on them so we can see them a little bit better. First of all, on the west side, since we're working west to east this evening, you're going to notice a bright reddish-orange star. That's a star named Antares, and it's a red supergiant star, this one right here. And when I say it's a supergiant star, its diameter is 700 times bigger than the sun. And the sun is over 1 million times bigger than the Earth. If you wanted to line up Earths across the face of the sun, it'd take 109 Earths to line one behind the other across the face of the sun. If you line suns up across the face of Antares, it would take 700 suns to go across it. It's huge. It only looks small to us because, you know, it's 550 light years away. This is one of those stars that will explode one day. It'll explode in a supernova. And when it explodes, and it could do it any day, could do it tomorrow, but it might be 1 million years from now. For a star, that's like not that long. When it explodes, it'll be brighter than the full moon. So it'll still just look to us like a pinpoint, an incredibly bright pinpoint in the sky. So that's Antares. Now it has a reddish color because when stars get big, they've got a lot of surface area and their temperature cools down at the surface to around 6,000 degrees. Our sun is 12,000 degrees, but it's a lot smaller. And so the colors tell us the temperature. So this is a cooler star than our sun, though it's giving off way more energy on all told. It's just over a great big surface area. As a matter of fact, if you put Antares and the sun the same distance apart, Antares would be 85,000 times brighter than the sun. So it may be cooler than the sun, but it far outshines it. Now, being red, it has the same color as Mars, and Mars often passes through this region of the sky. And a lot of people go out at night and they see that red star and they go, hey, look, there's Mars. And they think they're very smart. It's an easy mistake to make. I don't mean to mock anybody, but it's fooled people for generations and centuries. That's how it got the name Antares. The word Antares means the false Mars. And it's in the constellation of Scorpius the Scorpion. Antares is its heart. Its head is up here. And so we draw a line from the head down to the heart. The body comes right down to the horizon. And right now for us, it dips below the horizon, swings around. And then this double star here is a star named Shula, which means stinger, because scorpions have a stinger at the tip of their tail. So if we put some lines on this scorpion, you see the stinger and he dips down below the horizon. If we want to momentarily get rid of the ground, we can see the whole thing right here. It goes like this. Take it off and we should be, oh, they make it a little darker there, don't they? There are actually stars there, which you can see if you're in the right spot. And then we come back up to the heart and we have claws, one here and one here. Now I draw it differently. I don't draw the claws coming out of the heart. I have the claws coming out near the head. I draw a line across to here. Then I use these little stars to make a little claw. Then the other claw comes over here. And then I use these little stars to make another claw. It just makes a better scorpion, I think, but that's just the way I am. Now, once you find Scorpius the Scorpion, look to the left, the other side of the Milky Way, and you're going to see a neat little constellation called Sagittarius. Now, Sagittarius was a centaur. Now, if you remember your mythology, a centaur is a creature that's half man, half horse. And so it's got the body of a horse and where the neck comes up towards into the chest of a man and a man with arms and a head and the whole works. So I want you to look at this group of stars and see if you can see that. If you do, you need to tell me how you do it because I can't see that at all. And as if that weren't bad enough, he's also supposedly shooting a bow and arrow. Most people can't see that. But Sagittarius is actually pretty easy if you turn it into what most people see. And what most people see is the teapot. It's tipped up like you're pouring tea. This is the base of the teapot. We got a side here with a spout, a side over here with a handle, and then a lid on top. And looks like the Milky Way is coming out of steam. So once you find Sagittarius the teapot, remember I said about those pink patches, I'm sorry, the nebulosity. Look right above it in the steam here, you'll see a nice pink patch of light right there. And that, let's shut that off. That is one of those in our galaxy. Let's zoom in for a closer look. Let's center it. We'll bring it in a little bit closer. And let's check it out. It's quite beautiful. It's called the Lagoon Nebula. The Lagoon Nebula is about 100 light years from one side to the other. Now, remember, a light year really isn't a length of time. It's a distance. Like an inch is a little distance. A mile is a bigger distance. A light year is a huge distance. It's the distance a beam of light will travel in 1 year's time. And light travels at the incredible speed of 186,000 miles per second. So at that speed, you could go 7.5 times around the Earth in 1 second. That's pretty fast. If you go at that speed in a straight line for 1 year, the distance you cover would be 1 light year. So from this side on the right to the far other side is 100 light years. From top to bottom, it's, depending on where you measure it, 40 to 50 light years. It's a big cloud of hydrogen gas floating in space, but it's collapsing slowly on itself. And as it collapses, it makes these little dark spots where the gas is really condensing. And once there's enough gas there and enough pressures in each condensation of gases to create fusion in the core, it starts shining as a star. So the red is hydrogen gas. The reason it's red is because there are new young stars. All these stars you see in the middle are stars that form from it. Once they start shining, they're giving off a lot of ultraviolet light. The ultraviolet light excites the molecules of hydrogen that are floating around. And when hydrogen gets excited, it glows with a red color. So that's what what the red, why it's glowing red. It's actually an emission nebula. It's emitting light. It's not just being lit up, it's emitting light, whereas a lot of the light inside here is where it's just being lit up by the light of those young stars. And the stars in here are the beginnings of an open star cluster, not a globular like M13. This is the other kind of cluster. It's just in its infancy here. These are like baby stars. This is a place where stars are being born. Now, slowly over time, this nebula is going to disappear as the gas gets eaten up by new stars. And what will take its place will be a whole bunch of young stars. So let me show you where we can see a couple of those. Go back to Sagittarius, and right underneath, you see right under the teapot, two of those open clusters. This one right here, this one's called Ptolemy's cluster. Let's get it centered right there. And then a smaller one up here called the butterfly cluster. Now, if you've been around 100 million years ago, and I know that sounds like a very long time, but for stars, that's not that long. Neither of these clusters would have been here. There would have been clouds of hydrogen gas like the Lagoon Nebula, but that slowly condensed into stars. And once the stars start shining, their gravity increases, they pull the gas in. And the gas some of it dissipates, but most of it goes into the stars. So these are the young stars, the Ptolemy's cluster and the butterfly cluster. The Ptolemy cluster is named after Ptolemy because you can see that with just your eyes. You can see there's a group of stars there, and Ptolemy wrote about that 2,000 years ago. Now we're going to follow this Milky Way. Oops, follow it. Oh, let's bend back a little bit. Follow it up high sky till you're looking almost overhead. And you're going to see three stars that really, really stand out. They're called the Summer Triangle. We start with Vega, the brightest one, which is just to the western side of the Milky Way. It's the brightest of the three. We go down to Altair, then up to Deneb. This is the Summer Triangle. It's called that because it first appears in early summer, like end of June, early July. It starts appearing in the eastern sky. This time of year, it's pretty much up overhead at 9 o'clock. And right now we're looking at the sky around 9 o'clock. And it'll be visible right through to almost Christmas time. And then it'll disappear and won't appear again until late June or early July the following year. Now, that's not a constellation. It's what we call an asterism, group of stars that's easy to recognize in the sky. And each one actually has its own constellation. Well, I want to start with Vega because that's the brightest of the three. Vega is in probably the most challenging constellation of the three to see. It's called Lyra the Harp. To see the harp, there are several ways to see it. I tend to like it to look like what I think of as a harp, a triangular-shaped instrument with strings. So I just make a big triangle. I start at this star up here, come down to Vega and past it to this star, down to these two, then back up. Now, kids always say, well, shouldn't Vega be in the corner? That's for some reason we always want things in the corners. I tell them that's where a string broke, it went prang and made a bright star. And they seem to buy that. You can do it any way you like. In this program, the other way they do it is this little parallelogram right here, this little diamond shape, they say that is the body of the harp, that it's a harp like a lyre, like Nero would have played when Rome burned or something. And they will draw it like this. I wish I could make this draw it the way I want to draw it because I see it differently sometimes. But remember, it's really anything inside that polygon, so you can draw it any way you want. That helps you remember it. But it is handy to see that little parallelogram because the two stars at the bottom, the lower one on the left is called Sulfat, and the one above it is called Sheliak. And right between them is something you might want to find with a telescope. So let's zoom in here and see if we can find it. It's right between Sulfat and Sheliak. And what I want you to look for is something that sort of looks like a star, but as you in with your telescope, you're going to see it looks like, and if you haven't seen it yet, it's right here. It's called the Ring Nebula. If we magnify up, you can see it definitely is not stellar because no matter how much you magnify distant stars, they're still pinpoints of light. This will definitely have a diameter to it, and it'll look like there's a dark spot in the middle. So this is a nebula too. Now we've seen the Lagoon Nebula, and we saw all those pink patches of nebulosity in the Pinwheel Galaxy. Those are all places where stars are being born. This is just the opposite. This is where a star that was similar to our sun died. When stars run out of fuel, remember in their cores, they're turning hydrogen into helium. The hydrogen is the fuel and helium is the exhaust, so to speak. When you run out of fuel, your car stops, right? So when a star runs out of hydrogen, it's all been turned into helium, the star collapses because that fusion creates lots of energy and it pushes outward and keeps the star swelled up. Get rid of the fusion, gravity wants to shrink it. When it shrinks, the helium starts fusing and it starts turning into carbon and neon and a whole bunch of things. But eventually, a lot of stars like our sun get to the point where there's not enough weight to fuse carbon and helium into much else. And then fusion starts happening not in the core, but outside the helium core, and it pushes the outer layers away. There's not enough weight to keep them in there. They just go floating away into space, and they form one of these rings around the dead core of the star in the center. They're called planetary nebulas because remember I said in the 18th century, people were really searching for planets. Partly that was because they had discovered a new planet in 1781. William Herschel discovered Uranus. Of course, he didn't call it Uranus. He named it after the king. He called it George, after King George. And the rest of the world didn't like King George very much, so the name didn't stick. Kids loved that it was planet Uranus. It was originally called George. But other people all over the world, they find this new planet, there must be more. And these planetary nebulas have nothing to do with planets, but they do have a disc-like appearance, and they're round and small the way planets look in a telescope, especially the telescopes 200 years ago. So now we call these dead stars planetary nebulas because they originally resembled planets. So this one's called the Ring Nebula, and the Ring Nebula is 2,500 light years away. And it's about 2.5 light years in diameter. So it's much, much smaller than the Lagoon Nebula, which was over 100 light years across. It exploded didn't really explode. It went through its reactions and pushed the outer layers off. Don't think of it as an explosion. It just like pushes it away and then it goes drifting off into space. That happened about 7,000 years ago. When our sun dies, when it runs out of its fuel, it'll create something just like this. It'll wipe out all the planets. If we're still around, we've got to find a new place to be. But that's not going to happen for 3 to 4 billion years. So we got a little time to think about it. So that's in Lyra the Harp. Now, you may have heard that some stars do explode, and they do. Our sun will not explode. It's going to create this. But if we go to the next constellation, which is Cygnus the Swan, and the bright star Deneb, which means tail, that's the swan's tail. This is his body right here with a big wing coming out on this side. I like to draw a line across to the tail so give that wing some width. And the same thing, the other wing comes over here like this, and then imagine a line back to the tail. Then a long neck with a head down here, and he's flying right down the Milky Way. Well, we're talking about stars dying, and giants like Antares, when they die, they're not going to gently push their outer layers away. They're going to explode in huge explosions called supernova. And right off this side, this elbow here and this wing, right here, we can find a supernova. Let's I have to get it centered so it won't zoom off to the side. And if we fly in there, right here, we find the remains of a star that exploded. This one's called the Veil Nebula today because it kind of does look like a veil floating in space. And it's also known as the Cygnus Loop because you can kind of see it really does make a sort of a circular shape. This is all the result of a star that it didn't just gently push its layers away, it exploded in a supernova. This happened about 20,000 years ago. Now, when you have the Ring Nebula, the planetary nebulas, that stuff's expanding outwards at 1,000 miles an hour, which sounds pretty darn fast. This stuff's expanding outwards from where the core of that star was at 1,000 miles per second. That's significantly faster. And when stars supernova, they create everything heavier than iron. When stars all by themselves can make all the elements up to iron. Once you start trying to form iron in your core, it takes more energy than it gives off, so it's not stable, and the stars collapse and then explode in supernovas. That's what happened here. And in that explosion, when this star exploded 20,000 years ago, it would be like I talked about Antares exploding. It'd be brighter than the full moon in the sky. One of these happened, not this one, but one happened in 1055 AD, about 900 years ago, in what's now the winter sky in Taurus the Bull. And people saw it. The Chinese wrote about it. They called it the guest star. They said it was so bright you could read by the light of the star at night. And it was so bright you could see it during the daytime as well. Well, when that happens, it creates every element heavier than iron. Anything heavier than iron was created in a supernova. So if any of you right now are wearing jewelry, you have a wedding ring made of gold, earrings made of silver, anything that's like silver, gold, or platinum, that was something that was created in a supernova explosion. You have pieces of a supernova in your possession. Isn't that cool to think about? All the gold everywhere was created that way. That's something cool to think about. And we see the example of that right there in Cygnus the Swan. The third constellation in the Summer Triangle is Aquila the Eagle. And I have my own way of seeing Aquila. So I like to show you my way because I think it's the best. I guess that I do it. They normally draw Aquila like this. So let me just show you how it's usually drawn here. And I suppose these are supposed to be the wings. This is the head, kind of a weird looking head, and a tail down here. Takes a little imagination. I have to turn the lines off, but I will show you the way I envision it. I don't envision him flying. He's perched on a branch. Start with this star and draw a line over to this one, and this one. Those 4 stars in the row of the branch he's sitting on. The 2 middle stars, this one and this one, are his 2 claws grabbing the branch. Now think of him when you see an eagle sitting in a pine tree somewhere. So there's the branch, a claw there, and a claw there. This oval in the stars is the eagle's body with the tail dipping below the branch. Come up to these 2 stars, and those are his shoulders. And this triangle is his head. You could pretend to color it white for a bald eagle if you want. And the bright star Altair is his beak coming out of the side of his head. He's looking off to the side. Don't look for wings. When birds perch, they fold their wings in. I wish I could draw those lines on there for you to see it that way, but the program won't let me do that, unfortunately. So that's the way I see Aquila the Eagle. You can see it that way too if you want, or if you want, you can do it the traditional way, kind of like this, or maybe like that. I guess you can turn that into an eagle that way. For me, it's much easier to imagine the bird sitting on a branch. When you look at that beak, though, he's clearly looking this way. He's looking at this little group of stars here called Delphinus the dolphin, little diamond-shaped body, then a tail comes down. So if we put some lines on him, the lines on him, there we go. It does kind of look like a dolphin jumping out of the water. Nose on front, a fin on top, and a fin on bottom, and then a tail coming down. So we've got an eagle staring at the dolphin. Maybe he just jumped out of the Milky Way, if you want to get creative. And then we got the swan flying overhead, which with this nice little nature scene of an eagle and a dolphin and a swan, you might want a soundtrack. So we have something to create a little bit of music. Follow the Milky Way further to the northeast, and you're going to find a W-shaped group of stars called Cassiopeia. And Cassiopeia was a queen. Now, most people agree W's don't look much like queens. It's traditionally drawn as her sitting on her throne, sort of like this. Maybe I'm just opinionated, but I think that's a stretch. I think it's easier to imagine this is the queen's crown, a 3-pointed crown, and draw a line between those 2 stars, and that's the base where she'd put her head. But you got to be careful, because remember, we have the northern crown over by the ice cream cone, Boetes, we saw earlier. And in the southern hemisphere, we have the southern crown as well. So you got to be careful when you talk about crowns in the sky. It's better to say either northern crown, southern crown, or Cassiopeia, the queen's crown. Right underneath Cassiopeia, though, there's a group of stars that I want you to notice. It's the most distant thing you can see without a telescope. You see that fuzzy little patch of light right there? That right there, you just barely see it. You can see that outdoors. If it's a good clear night and you're in a dark spot away from light pollution, like you happen to have in Rangeley, if you live in Bangor or I live in Waterville, the sky is going to look a little more like this. Not quite so many stars. Sometimes that can make it easier to find the constellations because you get rid of all those other little stars. But there's something about a beautiful starry night where you get rid of all the light pollution, and you can see all these faint things like the Andromeda Galaxy. The Andromeda Galaxy is in the constellation of Andromeda, the Princess. This is her head. Draw a line down to this star and up towards Andromeda. This is her belt, and I draw a line back, so the triangle is her body. These stars here would be her arms, kind of going one way and the other. Then she has a leg here, and then another leg down to here. I don't know why they don't draw all that. They draw her in like this. But you can imagine any way you want. But the key is, once you find her head, go down to her belt and go up to her belt, and that top star just up and a little to the right, and you're going to see the Andromeda Galaxy looking like a little faint patch of light. If you have a pair of binoculars or a small backyard telescope, it'll clearly look like an oval fuzzy patch of light, kind of like what we're seeing here right now. And you'll tell it's definitely not star-like. Very nebulous looking, right? Well, this is a galaxy similar to the Milky Way galaxy or the Pinwheel galaxy. Pinwheel, we're looking right straight on from the top. The Milky Way, we're looking on edge on. This one, we're looking at a 45-degree angle. Now, if you had a camera attached, even to a small telescope, or you had a really big telescope, you'll see it better. Cameras can see things our eyes can't see, and big telescopes give our eyes the strength to see more. With something like that, it turns into this. It is a very, very beautiful object to take a photograph of. And in a large telescope, you can start to see some of the detail you see here. And a photograph of the big telescope shows the kind of detail you're seeing in this image. So this galaxy is just a hair. It's not as big as the Pinwheel galaxy, but it's a little bit bigger than our Milky Way. And it's the closest galaxy to our own. It's 2,500,000 light years away. Remember, the Pinwheel is 21 million light years away. So that's over 10 times further away. So 2,500,000 light years. And it's coming at us. Almost you look at, there are a trillion galaxies in the universe, and they're all moving away from us, except for a couple that are really close by. This is one that's coming at us. And the reason they're all going away is because the galaxy is expanding, from the Big Bang. But on a local level, sometimes you get things that move around each other. And sometimes galaxies that are close, their gravity pulls them together and they can collide. And this one's going to collide with the Milky Way. Now, when it hits the Milky Way, there will be no real collisions between stars, even though we're made of 2 to 300 billion stars, and this one's made of 4 to 500 billion stars. The distance between stars is so great that for the most part, these galaxies will go through each other. Their gravity will make them twist and turn. It'll change the patterns in the stars, and it'll move the stars around, but there will be very few actual collisions, which is kind of a good thing. They may unite and turn into one giant galaxy, or they may, depending on how they interact, they could twist and turn each other and go spinning off in 2 different directions. We see that happening in both ways. It's all about the physics of the situation, of how they interact and the angles they come at each other. But this is the most distant light you can see without a telescope, and it'll look like a little faint fuzzy star. Well, I want to finish up here with 2 more objects, and they're over in the eastern sky. Let's bring up our directions so you can know where to look to find them. You won't miss them. Remember, this is tonight around 9 o'clock or tomorrow night. And if you get out at 9 o'clock and look over in the east, you're going to see 2 bright stars. Hopefully you can see them here. Now, the Milky Way is coming down to the ground in the south, a little west of south. And it goes all the way overhead, and it comes back down to the ground up here in the northeast. Much fainter at that end, because that's not the center of the galaxy. In between the 2, you're going to see this bright star and this one, which is also fairly bright compared to what's around it. Well, the reason I'm pointing those 2 out is because those are not actually stars. They're both planets. Let's start with the bright one first. The bright one, which is further to the east, is the planet Jupiter. It's in the constellation of Pisces, the fish, which is a strange constellation. One circle is supposed to be a fish. This triangle right underneath Andromeda, the Princess, is the other fish, and there's a string coming down. They're tied in a knot, and the 2 fish are tied together by a string. The ancients had interesting imaginations. We have to give them that, right? Well, let's get rid of that. You don't need that to find Jupiter. Just look in the east and look for the brightest star. It doesn't come up until around 9 o'clock. So if you're out at 8, You're not going to see Jupiter. This one will be out, but Jupiter will come above the horizon around right around 9 o'clock. So Jupiter is definitely worth looking at. With binoculars, you might just start to see some of its moons. Now, Jupiter, turns out, actually has 79 moons going around it that we know of. That's a lot. Can you imagine looking up and seeing 79 moons in the sky? Well, if you're on Jupiter, you'd never see them all at once because they're going all around the planet. With a backyard scope or a pair of binoculars, you won't 79 moons. You'll see 4 at most. There are 4 big moons and 75 little tiny moons, which we can find with like the Hubble Space Telescope or by the probes that went to Jupiter to see it up close. If you have a small telescope, this is what they'll look like. This will be the pattern they're in tomorrow night. Now, right here, you can only see 3 of them. 1, 2, 3. The third one will probably be behind Jupiter. Now, if we want to, we could, let's jump back and see where they are tonight. Because remember, I said I set this for tomorrow night. Let's jump back and let's change the date back to today, the 31st. There we go. And we'll see that they're in a different position. Now we see all 4 of them. They move quickly. So every night you look, they're going to be in different positions. So Jupiter's here. Then we've got one right in close. So tomorrow night, it'll probably be behind Jupiter. That's why we're not seeing it. They orbit. We're looking to orbit edge on. So they seem to go back and forth. 1, 2, 3, 4. So 2 and 2. Sometimes all 4 are on the same side. Sometimes it's 1 on one side and 3 on the other. And sometimes you only see 3 of them, like we might tomorrow night. When you look at Jupiter, you're going to see these dark bands. You won't see the color you see here. The color shows up in photography. With our eyes aren't very good at faint light. When we see things that are faint, we see them in grayscale. We see black and white. So you'll see these bands, but they're going to look like gray bands against a white planet. Take a picture and you get the color like we're seeing here. And by the way, these moons won't look this big. The program is making them look bigger so you can easily see them. They're much, much smaller than Jupiter here, much, much smaller than they appear here. They'll look stellar, like little pinpoints, but they'll be nice and bright. You won't miss them. They really do stand out. But here they look much larger than they actually appear in the sky. So Jupiter, just so you know, is the largest planet. It's 1,000 times larger than the Earth in volume. And there's no ground. You know how you put those little rovers on Mars to go exploring? We can't do that on Jupiter because there's no ground to drive on. It's all clouds and gases and liquids deep inside. And the wind blows through those clouds at over 100 miles an hour. In one of these bands, it might blow east, and the next band, it might blow west. Back and forth it goes, creating big storms like the famous red spot, which is very often very difficult to see with most backyard scopes. Well, that's the bright one you can see outside tonight. It's basically about 450 to 80 million miles away. The next one, being fainter, the other planet, is fainter. So do you suppose it's closer or further away? Think about it. It's further away. This planet is 1 billion miles away. And this one, well, let me show it to you, and I think you'll know which one it is. We zoom in on it with our telescope, and you'll want a telescope to look at this one to see it well. You'll discover it's the planet Saturn. Now, if you look at it with binoculars, you'll still see it, but you won't clearly see those rings. You'll get a sense that the object is oval shaped. That's because of the rings, but you won't be able to resolve those rings out. You need a little more both magnifying power and light gathering power. The big thing a telescope does is it gathers more light. Think about outdoors and that your pupils get big. But how big can they get? But imagine if your pupils could get to be, 8 inches in diameter, how much more light would come into them. That's what a telescope does. All the light that hits the lens or the mirror in the bottom is squeezed down so it'll fit inside your pupil, effectively making your pupil that big around. When you have more light, you can see more detail and you can see fainter objects. Well, Saturn's very cool. These are all some of Saturn's moons. In most cases, I looked at Saturn the other night and I only saw this one. This is Titan, the largest moon. The other ones are very faint. And again, they look much smaller than they do here. Saturn itself is 700 times bigger than the Earth, and it's made of clouds and gases too, so you can't land on Saturn. The rings are made of ice, water ice for the most part. So if you took a chunk of Saturn's rings and melted it, theoretically you could drink it. I don't know what impurities are in there, but it's water. frozen to about 250 degrees below zero. But it's not a sheet of raw water. It's not like Rangeley Lake frozen in the wintertime. It's more like the crushed ice you have in your soft drink, your iced tea in the summertime without the iced tea. And there's millions and millions of these little particles of ice, and they're all whizzing around Saturn at like 20,000 miles an hour. So it's like an asteroid field. From the inside edge to the outside edge right here, there's about 35 to 40,000 miles. So they're very wide. The interesting thing is if you measure the thickness from top to bottom, there are points where it gets to be almost a mile thick, but most places it's less than 100 yards thick. Think about that. For 30 to 40,000 miles wide, but most places less than 100 yards thick. So if you tipped Saturn up on edge and brought the rings down at the 50-yard line of the Super Bowl, the rings would fit between the goalposts and extend 30 to 40,000 miles into the sky. Wouldn't that be a halftime show, huh? We wouldn't want to do that, but it's an interesting thing to think about. So those are the two planets you can easily see outside tonight, both in the eastern sky, and Saturn will be the fainter of the two, and a little to the west. Jupiter will be a little further to the east. Saturn will be up first, and Jupiter will come up a little after the sky tonight. I hope you've enjoyed what I've shared with you. I'll be glad to take any questions anyone has. You can, if they're in the chat and Sarah wants to read some, I'll be glad to do that, or we can take them in person. I'll leave the stars up in case you want me to point something out. Any questions anywhere? I don't know if there's a way for them to signal you to let them talk, or how we want to do that.
Yeah, they can like raise their hand. They can also pop questions in the chat, or there's a little Q&A feature. So I'm kind of looking at both of them. Also looking to see if there's anything on Facebook Live. It doesn't look like it though. Doesn't look like we have any questions.
We had one earlier. Okay. Well, I hope you all get outside some night soon. It's supposed to be clear tomorrow night, and hopefully the grass and stuff won't be all wet like it is right now from the rains all day today. And see if you can see some of the things I just showed you. They should all be out to see tomorrow. So thank you very much for coming out tonight and enjoying the sky with me. And I hope you enjoy full skies, because you have incredible skies in Rangeley. I envy you of that. Here in Waterville, it's not quite as good. Thanks, Sarah. Appreciate your help this evening.
Thanks, John. So if you guys have any questions, feel free to pop them on our Facebook page anytime. We can always kind of get any questions you have to John if you think of any later on. I know we have 2 more Dark Skies events this year. One of them's not a planetarium. It's a video that's at the Rangeley Theater called Defending the Dark. It's supposed to be really good. I think it just premiered this summer at Maine Film Festival.
It did.
Yep. So I think that one's supposed to be pretty good. So that's coming up in October. And then we also have another Dark Skies event happening September. I believe it's 26th.
Yeah, we changed the date at one point because of a conflict, but there is one for late in September. And if it's a nice night, I'll be coming to Rangeley and we'll do an outdoor one.
Yep.
And if not, we'll do another thing in Stellarium. We'll see how the sky changes in the next month.
Yep.
And if you come to see Defending the Dark at the theater in Rangeley, right now we're trying to rig it so we can do this sort of thing, but on the theater screen. I did that at the Maine International Film Festival in July, and seeing Stellarium on a screen that's 20 feet wide and 10 feet tall was pretty awesome.
Yeah, that sounds awesome. Yeah, I know we have a showing scheduled for 6 and 8, I believe it is. I know Rangeley school students have free admission, so that's pretty awesome too. So if you're local to Rangeley and have a kid that's in school, they can get a free ticket to see it. So that's pretty awesome. But otherwise, we hope to see you guys kind of around. Our office is always open Monday through Friday. So stop in, feel free to come ask us any questions you may have about the area. And hopefully we will see you in person in September.
Yeah, I hope so too. I like doing this, but I would much rather be outdoors looking at the real sky because it's pretty spectacular.
Yep.
Great. Thank you, everybody. Good night.
Thanks. Have a good night, everyone.
Good to see you again, Sarah.
Good to see
Good
you
luck.
again, John.
Good luck at school.
Thanks.
Bye-bye.
Bye.